All right, so these videos are for the people that are able to finish all of the substitution integral practice early. All right, so this topic is differential equations, and this topic is worth about 5%, maybe 7% of the AP exam. So in terms of teaching it and spending a week learning differential equations, I think our time is better spent really understanding and being able to do all the topics that are worth 20% of the exam. But for the people that are able to finish the substitution practice early, I think this is a good way to spend that extra time, all right, getting that last little bit of the material for the AP exam. That way, if there's a question that you see that's related to differential equations, you don't think it's impossible. You can actually try it and maybe get those last extra points that pushes your score up a bit on the AP exam. All right, so it's not something that you necessarily have to know inside and out, but there are certain problems that if you have a little bit of an understanding of differential equations, you can pretty much get the answer pretty quickly. All right, so let's go through some basic different things with different equations, and then there's a practice on WebAssign where you can kind of put some of these skills to the test. All right, so many times in the real world, we know how something is changing. For instance, you could measure the rate at which the glaciers are melting or which water is flowing out of a pipe or something like that. All right, and you can use that information about the change in order to figure out information about other things that are going on or the formula for how much water is left in the tank or all of that. All right, so this type of equation that involves a derivative, again, because remember derivatives have to do with change, are known as differential equations. So the basic idea is if there's an equation, something with an equal sign, where there is a derivative inside of the equation, that's a differential equation. All right, so here's some examples of differential equations. So y prime, that's a derivative, equals 3x squared. So we know the water is pouring out of the tank at a rate of 3x squared or something like that. Sometimes the derivative is related to the original function, so you can get like y prime, that's what makes it a differential equation. But you also have the original function y and some other x stuff. All right, we're not really going to talk about these in this class, all right, but you could also have y double prime, that's the second derivative. You have a y prime and a y. All right, so the basic idea is whenever there's any type of derivative in an equation, it becomes a differential equation. All right, a solution to a differential equation is any function y equals f of x that makes that equation true when you plug it in. All right, so if I plug in this whole function y, of course, I'll also have to find the derivative to plug it in for y prime. If that makes the equation true, then that's a solution. All right, so one thing you'll be asked to do in terms of differential equations on the AP exam might be, is this a solution to the differential equation? All right, so they'll give you a possible solution, and they'll give you a differential equation, and is this a solution? Well, the y here is going to plug in for that y, but we also need to plug in for y prime. So the next thing I need to do is figure out what is y prime. All right, the derivative of e to the negative 3x is going to be negative 3 e to the negative 3x plus 2. All right, so that's the derivative of y. So I'm going to plug that into my equation. And now I just want to simplify to see if I get an equation that's always going to be true. All right, so the first thing I would do is distribute that positive 3. This negative 3 e to the negative 3x and the positive version are going to cancel out. I can combine those like terms. And you see this equation is definitely true. 6x plus 11 is definitely equal to 6x plus 11. So this was a solution. If I got down to something like 6x plus 9 equals 6x plus 11, well, that's not going to be true. So we know it's not a solution. But if I plug in this and then take the derivative, I plug that in, and I get something that's true, that's a solution. All right, a particular solution, so there's technically like an infinite number of solutions to your differential equations, because I would add that plus c, because when I take the derivative, that plus c goes away. All right, so there's a lot of general solutions. A particular solution is a very specific solution, And that normally when you have to solve some extra condition, such as an initial value or going through a specific point or something like that. All right, so the way it might look like this is you have this differential equation, y prime equals 2x. You want to find a solution that also goes to the point 2, 7. All right, so if we have y equals x squared plus 3, let's see, 7 equals 2 squared plus 3, 7 equals 4 plus 3, 7 equals 7. So this equation does go through the point, and now we have to make sure it's actually a solution to the differential equation. Well, y prime is 2x. Well, that's basically the original equation as well. So y prime, you get 2x equals 2x. All right, so this is a particular solution because not only does this function solve my differential equation, it also goes through the point 2, 7. All right, particular solutions are called particular because there's not very many that solve that specific scenario, versus if we took out the 2, 7 part, there's an infinite number of solutions to the problem. All right, so by putting extra conditions on my problem, I have to get a particular solution, a very specific one, rather than just a kind of general one with a plus c or anything else. All right, so that's kind of the first stage of understanding differential equations. All right, it's any equation that has a derivative in it, and a solution is an entire function that when you plug it in, it makes the equation true. All right, so that's the first step of understanding differential equations.